Hi, and welcome back to FactBird's Mastering OEE and Manufacturing course. Today we'll be going through Lesson 8, which is FactBird's practical guide to calculating OEE. Included in this will be calculating total capacity utilization and also giving you a waterfall analysis example. So let's put together what we've learned so far in the course with a full OEE calculation example, including stop cause categorization. You'll find the Excel worksheet for this exercise in the accompanying article for this lesson in FactBird's Manufacturing Intelligence Academy. So we'll start by grouping stop causes into availability, performance, and quality losses, and then taking the product of them to get our overall total capacity utilization rate. Then we'll look at the waterfall method using the same data to get a breakdown of TCU, OEE1, OEE2, and finally OEE3. As you'll recall, OEE equals availability times performance times quality. At FactBird, we like to take into account all the time available for your equipment when making improvements, and not only the scheduled production time, also known as operation time. This means that availability losses include time where there is no activity at the line due to having no night or weekend shifts, for example. So here, we're calculating total capacity utilization, also known as asset utilization. In short, TCU takes into account all available time for your equipment, while traditional OEE calculations only look at scheduled uptime. Now, let's take a deep dive into that calculation using actual stop categories and downtime data. For this example, we'll look at a week for a production line with a total equipment time of 168 hours. This is the total amount of time our equipment is available for production for the time period. Let's calculate the availability losses. First up, we'll look at where there has been no activity at the line. Throughout this week, the production line is manned for 2 8-hour shifts, 7 days a week, which comes to 112 hours. This gives us 56 hours where no production is scheduled. We'll keep extraordinary unmanned days at 0. Now, let's look at the non-production activities. Here we have 3 stop categories. First, planned maintenance equals 8 hours. Second, validation of equipment equals 4 hours. And third, testing new product, which equals 2 hours. Our final group of availability losses we'll look at are batch-specific non-production activities. Here we have 24 hours worth of downtime. Adding all of these availability losses up, we've lost 94 hours of availability. Subtracting our availability losses from our total equipment times leaves us with 74 hours of operation time. Then, by dividing 74 hours by our total equipment time of 168 hours, we end up with an availability rate of 44%. Now, let's look at our speed losses. In this example, we can say our maximum speed is 240 pieces per minute. And the actual speed our line is running at on average is 161 pieces per minute. Then, by dividing the actual speed of 161 by the validated maximum speed of 240, we have a performance rate of 67%. Finally, let's add in our quality losses. For this example, we'll say we start with a batch size of 100,000 pieces. And let's say we have 5,000 pieces of scrap in this 100,000 piece batch. We then take our right first time quantity of 95,000 and divide that by our batch size of 100,000 to get a quality rate of 95%. Now that we know our availability, performance, and quality rates, we can calculate a 28% OEE. And remember, at FactBird, we call this OEE score total capacity utilization because we take into account all available time for your assets. Now let's go over an OEE waterfall chart example. So 28% OEE doesn't sound great, and we know we want to do something about it. But where should we start? Thankfully, FactBird's waterfall technique for breaking down OEE into TCU, OEE3, OEE2, and OEE1 helps us narrow down what to improve first. Plotting the same data in a waterfall chart will give us a good overview of our equipment's effectiveness. As you can see in the chart, we have 4 stop categories. First is no activity at the line. Second, non-production activities. Third, batch-specific non-production. And fourth, loss during operations. Please note that the loss during operations has been calculated as time losses in the waterfall calculation as opposed to a unit-based scrap and quality losses. This is a good example of different calculation methods leading to the same result. However, it's a lot easier to visualize where your losses are using the waterfall technique. So here we can clearly see how stops take away from our total equipment time potential, leaving us with 46 hours of valued operating time. We also have a more granular view of OEE. You can see here that OEE1 is 63%. In most cases, factory floors are looking to have OEE1 around 75 to 80%, so this is low and something that needs to be addressed. What I'd like to focus on actually is OEE2, which is 47%. So that's changeovers, cleanings, etc. Oftentimes when we go into factory floors, they're not paying as much attention to OEE2, so they just take for granted that the SLA is being met for changeovers and cleanings. And what we often find is that they gain a lot of OEE uptick by focusing on those things. So if you have a 30-minute SLA for cleaning, oftentimes we'll come in and they're running at 37, 40 minutes, but they're not paying attention to it on a daily basis. So once we have FactBird installed in there and they really start to focus on it, they actually gain a lot of OEE uptick in OEE2 in particular. So those are some of the nuances as you start to calculate OEE and really understand it on the factory floor, and it's backed up and validated by data, where we start to see some of the biggest gains. And then finally we have OEE3, which is non-production time, so that's meetings, planned closures, things like that. That leads to a TCU of 28%, which is not great, but again, now you have a granular view of each OEE category and where you need to attack and make adjustments to be better. So keep in mind, this is just an example of how to calculate OEE, and that it's not uncommon to have tweaks to how this is done from company to company. And that's it. Thanks for listening. You should now have a deep understanding of OEE. Join us in the next lesson on common issues with measuring OEE and best practices for implementing OEE. See you next time.